Hey, this is Mr. Ferguson,
And Mr. Hunter.
and we're doing lesson 2.1. Today we're talking about matter. Since chemistry is the study of matter, that would be a good place to start.
All right, the first objective is, well, to define matter.
And then we're going to review the atom as the basic building block of matter.
Then distinguish between elements and compounds, substances, and mixtures, homogeneous mixtures and heterogeneous mixtures. A lot of distinguishing.
Okay, let's get to it.
All right, so as we're talking about matter, matter's definition, it has mass and volume. Atoms are the building blocks of matter. So everything that we see and touch is made of matter, and of course, therefore, has a mass and a volume.
So we're going to deal with this red block here, and pause it if you need to, write down the definition. We're going to make a little graphic organizer here when we're
Which
done.
you should copy into your notes.
Okay.
So the first step now is to see what types of matter there are. We can always subdivide things. So the first subdivision would be
substances. One class of matter is substances, and this is probably one of the classes that we work with most often in chemistry. These are forms of matter that have constant composition and properties. So basically we would say this is a chemical. This is one substance. This is one thing.
All right, and then the second tier, or the second thing to break it down into, is a mixture. These are two or more substances together. Each component retains its own properties, and it's a variable composition.
So you can add 2, 3, 4, 5 things, put them in any amounts, and it's still a mixture.
All right, so let's go back to substance, and then go down to the next block.
Okay, so we're going to subdivide substances into two more levels. And the two primary kinds of substances are elements and compounds. And I know this is a review of things you've had before in science, but elements are forms of matter where all of the atoms in the sample are exactly the same.
Yeah, the same atom. And of course there are compounds, and these are two or more elements chemically joined to form a new substance. And of course a compound and element are two different definitions that you also have to know.
Okay, let's go back up into the mixture, and we're going to break mixtures into some subgroups as well.
You can probably draw this better on your own, fan them out more. But the first type is a heterogeneous mixture. So heterogeneous mixture, and it's evenly dispersed components, also known as a solution. So if you look at it, you could not differentiate between the different parts. It would all look the same.
It's very smooth and even, no chunks of anything that are visible.
Looking at well homogenized milk that hasn't gone sour, just looking at milk, that's actually a colloid. But looking at milk, it's a solution, looks like a solution, because if you look at it, you can't tell the difference. A better example would be, salt water.
Okay, you can look at it, you can't really tell that it's any different from regular water because the salt is so evenly dispersed.
Yep.
And then the other kind of mixture is a heterogeneous mixture, so it's the same root there, but a different prefix on the front. Hetero means different. These are the components not evenly dispersed, and these are mixtures that very often have distinguishable pieces of one kind of matter or another in them.
Yeah, a very easy common world example of this would be like a pepperoni pizza. You can tell the difference between the pepperonis and the cheese.
Sauce, crust, there's all these different components. So we're going to go on to some additional slides and kind of explore some of these things in a little more detail. Make sure you copy down this graphic organizer and know those differences. All right,
so here is the an elements talk, or an elements slide. The periodic table is, well, a table of elements. Everything on there is an element, and the definition of an element are all the atoms are the same. So to the right here, we have a picture of tin. We know tin to be a pure element. So all tin atoms would look as close to identical as possible when drawn by a human hand. Now, let's not be confused or get lost when we talk about elements. Sometimes elements are not single atoms. Let's talk about hydrogen, for example. We all know that hydrogen is special and neat in that it is known as a diatomic element, and hydrogen atoms are just two of the same atom chemically hooked together. So if you see two hydrogens together, that is still an element because it's only two hydrogens. Another good example, even more difficult, is sulfur. Sulfur is another element, and it comes with 8 atoms connected together. They're actually in a ring.
I'm not drawing 8
That's
of them.
okay. But
Okay.
so sulfur has 8. It's S8. There are 8 sulfurs, but it's still an element because it's the same atom.
So to kind of make it so we're not always drawing little random circles to represent things, we have a shorthand. So if I want to represent atoms of the element tin, I'm just going to write tin's chemical symbol, SN. So that could represent a sample of tin, or it could represent a single tin atom.
Next
Now
one
if
would
I
be
wanted to write hydrogen, I would write H, but since we know hydrogen's diatomic, what do we have to do?
H2, little
We
2.
put a little 2 to show that the hydrogen units are in 2s.
And then the last one I mentioned was sulfur. That would be written as S8. And it's just one of those facts that you
So
learn.
those little subscripts, which is the number that comes low and after, will denote how many atoms are in that particle
Correct.
that are joined up.
All right, let's take a look at the next thing. All right, so here's looking at compounds. And we know that compounds are 2 or more different things or elements combined.
To make a new substance with new and different properties.
That's a better definition, thank you. So as we can see, here is potassium. It is a pure element, and it is a shiny and very malleable and easy to cut metal.
Right, I just took a blunt, like butter knife type thing and lopped off a chunk of it.
And then we're going to combine this with iodine. Iodine's another element, I2, and you can tell it's purplish gray powder looking stuff. Nothing too exciting. But when we combine them together, plus yields, you combine it together and we make potassium iodide. And we can tell potassium iodide looks nothing like the other two, so we probably did
what? It
what?
looks kind of like sugar. It's a crystalline material,
so-
whitish crystal.
So obviously we have performed a reaction and have an entirely new substance. So this is now a compound, 2 or more different things being chemically combined together.
So let's show them how to, and we would represent that process in the chemical shorthand.
So potassium is K, iodine is another diatomic, I2 yields Ki. And that's your first chemical formula you'll probably see to this point.
So when we have things that are chemically joined, we write the symbols of the elements right next to each other
Together.
with no plus signs or anything in
Or
between
we
them.
use these telling you, hey, they're connected as
How
well.
many?
All right, so next we have this nice example video of what an element is like.
There's potassium.
It's just potassium going in water.
You can see why we store this in a special place. It's stored underneath mineral oil
And not
because
water.
that was water. And you know, when iron gets wet, it gets rusty. When potassium gets wet, it goes boom.
So here now we took the compound, I believe potassium iodide, and put it in water just to illustrate how a new compound doesn't always have the same component reaction as its parts.
Yeah, so potassium iodide, when it hits water, doesn't
just-
really do anything except dissolve.
Yep. So they make new properties.
New substances that have very different properties than the elements
And their
that make them up.
component parts. All right, next look at the next slide.
To illustrate mixtures then, I took some sand and sucrose and we just dumped them in a dish. Sucrose is the chemical name for sugar. But you can see sand, there's areas of sand and there's areas of sugar crystals, the larger kind of transparent things. And that tells us that this kind of mixture is the chunky, unevenly distributed, that we use the word heterogeneous. So if you can see visible
Differences.
pieces of things, it's heterogeneous.
So then in the next one we have over here, I believe, is sugar again.
Sugar, and this time there's a little video clip.
And it's putting it into water. He's just dumping it in there, you know, willy-nilly, no sciencey measuring.
Yeah, I could have dumped any amount in I wanted to.
And he stirs it together, and you get up close, and you really can't tell any difference. So now we're going to consider this to be a solution, also known as a homogeneous mixture. So there you have it. And that's the differences between mixtures. All right. All right, post-video questions. We have 3 of them for you to answer. The first thing is, what kind of matter is represented here to the right? It is brass.
You can see there's some brass dumped out into a dish.
Yep, shiny little pellets. Please tell us what type of matter this is. Is it a compound, element, mixture, etc.?
Homogeneous mixture, heterogeneous mixture. What type
You
is
might
it?
need to do some research on your own. And then number 2, we want to know what kind of matter is created when you make a pitcher of powdered lemonade. So again, is it an element, compound, mixture, solution, heterogeneous, homogeneous, etc.? And then what's the difference between an element and a compound? We look forward to your answers tomorrow.
We'll see you then.
Have a good one.